Let's look at another example in this video. This one is going to be a one-sample, two-tailed t-test. So I want to consider this an exercise again. And so this time I'm going to introduce the problem, ask you to pause the video, work it out yourself, and just use this to come back and check. It's very important on these kinds of things that you practice doing some work, and this will give you a nice way to do some work and then check it. So a bottle of acetaminophen is labeled as 60 milligrams per tablet. A sample of 40 tablets are taken and carefully measured. The tablets in this sample had a mean mass per tablet of 596.3 milligrams with a standard deviation of 4.7 milligrams. At a significance level of 1%, is there enough evidence to conclude that the tablets have a mean mass different than 600 milligrams? See if you can work this all out. Work out every part of the hypothesis testing procedure and use the calculators for shortcuts if you want to, and then come back and test your answers against the solution set as we go forward. Press pause now. Okay, so the first thing we have to always do is check the conditions and determine the type of test. Here we are testing the mean for one sample against a hypothesized mean. The sample size is greater than 30. So the sample means are distributed approximately normally regardless of what the distribution of individuals looks like. And the population standard deviation is unknown. Those are enough to do a one sample t-test. Okay? We're testing for a difference in mean, that is a difference between the mean that we have and the hypothesized mean, the sample mean and the hypothesized mean. And so that's going to be just any difference, not a bigger or larger one. So that's going to be a two-tailed test. So if H naught is mu equals 600, H alternative is mu not equal to 600. So a two-tailed test. Well, luckily the calculator has a nice little app for that. So we just do the TI-84 app, do t-test, which is, this is the TI-84 at least, so this is, let's see, it would be stat, choose tests, and then choose stats here, enter the stuff in. So the mean, the mu naught mean, the null hypothesis mean is that there's 600 milligrams. So we're going to assume the labeling is correct, right, unless we got evidence otherwise. X bar was 596.3, S sub x is 4.7, N is 40, and we're doing a two-tailed test, so the alternative hypothesis is that mu is not equal to mu naught. If we hit calculate, we get the middle screen, hit draw, we get the last one, and so we calculate it, we get a t star value of negative 4.9789, etc. That's and the alternative hypothesis is mu is not 600. There's the p-value. Be careful. See this e negative 5? That means times 10 to the negative 5th. So that means we're actually going to take the decimal and move it 5 places to the left. Okay. There's x bar, s, and n. And then over here we get the distribution here. Well, this is the p-value rounded off to probably like 4 decimal places or 3 or 4 places, and which is p up. P is 0 up that far, 0.4 zeros and then a 1 and some stuff. So to 4 decimal places, P is 0. And so that's why you can't really see it here, but normally this would be a little area on the left and a little area on the right. Each one of those is P over 2. Here, there's such a small area, you can't really see it. So P is definitely less than alpha, so we reject the null hypothesis, and the conclusion is that a one-sampled, two-tailed t-test was performed on this sample of 40 tablets, resulting in a p-value of 0.0000013. Therefore, there is very strong evidence that the mean mass per tablet of these drugs is not 600 milligrams. Any kind of reasonable alpha, that p-value will be less than alpha, so we're going to end up rejecting the null hypothesis in this case.